Welcome. My name is Dylan Roberts, and I'm a master's candidate at the Royal Military College. I'm currently being supervised by Dr. Iris Koch and Dr. Kayla Weaver. Today, I will be presenting my work on estimating the number of industrial facilities acting as PFAS point sources based upon their current and past activities. Per and polyfluoroalkyl substance are a province-wide concern, as they are a vast group of anthropogenic and highly persistent chemicals that have been linked to numerous human health problems. Despite the well-documented nature of PFAS usage in industrial applications, little is known about the number of facilities thought to be points of release. In order to address this information gap, I've used publicly available information resources to accomplish four separate objectives. The first, the identification of industrial sectors of concern for PFAS. Second, the cataloging of facilities of concern. Third, the evaluation of identified sites using decision-making frameworks. And fourth, the development of an interactive GIS map of the facilities. As part of the first objective, 6 industrial sectors were identified. The first being waste disposal sites with 2,400 individual facilities. The second being wastewater treatment plants with 499, followed by metal product fabrication facilities with 146 sites, automotive manufacturers with 128 sites, paper making facilities with 47 sites, and petroleum product and distribution facilities with 34 sites. In order to demonstrate the development of decision-making frameworks, the one developed for the paper making industry will be used. To classify a facility within one of 3 possible predictions for the likelihood of PFAS usage on site, decision-making frameworks are developed for each industrial sector. Questions could be informed upon 3 types of information. The first being industry-specific questions, such as the advent of novel PFAS applications within the industry. The second type of questions are site-specific questions. The third are based upon publicly available information, such as the Hazardous Waste Information Network. In total, over 3,200 sites were evaluated, all of which being classified between the likely or possible outcome. This is due to the nearly ubiquitous nature of PFAS in industrial settings after the 1950s. Plotting these facilities over Ontario, we can observe that the landfills and wastewater treatment plants are spread throughout the province, while the remaining industrial sites are largely in southern Ontario. As for the development of a GIS map, focus has been on developing the functionality of the map to provide the user with details regarding the unique site. For example, using the AV Terrace Bay Mill, we can see that the mill is classified as having possible PFAS contamination. In summary, the 4 initially stated objectives have been met. 6 industrial sectors have been identified, 3,200 individual sites have been detailed and cataloged, 6 decision-making frameworks have been developed and used to evaluate the sites, and a GIS map has been produced to detail each site. In terms of future work, the refinement of existing decision-making frameworks is to occur as new information is published. Subsequently, the quantification of historic sites, as there is no central source of information regarding these sites. Finally, the identification of industrial sectors of concern. As of yet, 20 additional sectors of concern have been identified, covering over 200 facilities across the province. This concludes my presentation. I'd like to thank those who have helped make this project possible, starting with Luciana and her team at the MECP for their input and suggestions throughout the work. I'd also like to thank Dr. Zhang for his help regarding the identification and location of wastewater treatment plants, and I'd also like to thank Jeffrey and Jeremy from the ECC for their guidance regarding fire codes and applicable standards.